Test. Okay, Assalamualaikum and hello. My name is Wan Muhammad Hasief bin Shahar. Today I will present my OEL Lab 3 Laboratory Module 5 DC machine. Okay, introduction. In this experiment, we want to characterize DC machine based on simulation or real approach in laboratory and to observe the relationships and characteristics between different parameters. Only 3 out of 5 types of DC machines learned in classroom are being experimented. DC machine experimented are 1. DC series motor, 2. DC shunt motor, 3. DC separately excited motor. Okay, there are 5 parts of experiment. Part 1, connection and motor direction of control for DC series motor. Part 2, torque speed characteristic for DC series motor. Part 3, speed control for DC series motor. Part 4, magnetization curve plotting for DC shunt motor. Part 5, magnetization curve plotting for DC separately excited motor. Okay, this is the result for part 1, connection and motor direction control for DC series motor. Okay, connection on the panel of the DC motor machine. Before reversing the connection leads of A1 and A2 terminals, the direction of rotation of the motor is anti-clockwise. And after reversing the connection leads of A1 and A2 terminals, the direction of the rotation is clockwise. This is because we changed the terminal, so the rotation of the motor also change. Okay, for part 3, part 2, torque speed characteristic for DC series motor. There are 3 different voltage value are being experimented. The value are 120 volt, 110 volt, and 100 volt. Okay, for this part, I will show you the table result of 120 volt. Okay, as we can see from the speed torque speed graph, when EV is 120 volt, when the speed decrease, when torque increase. And for the current torque graph, you can see that the current increase when torque increase. Okay, for part 3, for speed control for DC series motor, this is the table for the result table for part 3 experiment. Okay, this is the graph plot for torque resistance graph. You can see that the speed decrease when the resistance increase, and for the current resistance graph, you can see that the field current increase when the resistance increase. Okay, for part 4, DC shunt motor, there are 3 different speeds are being manipulated: 1500 rpm, 1600 rpm, and 1770 rpm. Okay, this is the table result for when speed is 105,000 rpm and V in is equal to 220 volt. Okay, as we can see, when IA increase, armature current increase, VT decrease, and IF decrease. The resistance increase, IA decrease, IF field current decrease, armature current increase. Okay, from the armature voltage versus field current graph, when speed is 1500 rpm, you can see that voltage increase when field current increase. Okay, next, the last part 5, magnetization curve plotting for DC separately excited motor. Okay, this is the table, this is the result for the DC separately excited motor. You can see that when VA increase, IA also increase, and the speed increase. But when VF remain constant, IA also remain constant. You can see that DC separately excited motor can maintain field intensity and is able to get good output at terminal voltage. Okay, for the conclusion, this report also shows the characteristic in DC series torque speed and speed control. In torque speed, DC series we analyze the torque versus speed and current versus speed. We see different results between the two. In speed control, we analyze RPM versus resistance and current torque. Okay, for shunt, we see the result of voltage terminal VT and field current IF. For DC separately excited motor, we analyze the terminal voltage and field current. In conclusion, this report has achieved ability to perform experiments to characterize DC machine based on simulation or physical approach, and the ability to observe and analyze the obtained result of the experiment and relate them with theoretical and fact learned in books and class. That is all for me. Thank you.